Okay, good afternoon. My name is Dr. Gil Happert-Graf, and with me on the stage is Mr. Yochai Kiryati. Before we even introduce ourselves, I would like to start showing you one of the first demos in WPF, but a very powerful one, turning the page. Well, in the last 1.5 years, I've been introducing WPF to customers and potential customers and even family and friends, maybe 2-3 times a week. And I've been showing them many presentations and demos, and from all demos, this is the one that knocked them down. You see, when I turn the pages and I start working with all the applications here, the demos, the trees, the tabs, the buttons, and so on, they are amazed. And I'll tell you why. Because during all our experience with computers, we usually think about it as hardware panels. We have the buttons, the push buttons, we have the radio buttons, and all of a sudden, you put the application on a piece of paper, and it's flexible, and it's turned from the right to the left, from the left to the right. On one side, you have the buttons. On the other side, you have the word processor. It's really nice, isn't it? That's why people are amazed. But to tell you the truth, I hate this demo. I really hate it. And I'll tell you why I hate it. Because it brings no value to the user. After 3 or 4 times that you are turning the page, you got sick of it. It's a hard work to catch the corner of the page and to turn it and to drag the mouse, drag and drop is a difficult operation. And what you get out of it? Almost nothing. And I'll tell you something more. I think that those who designed this demo hate it as well. That's the reason why they put the previous page and next page buttons on the upper left side, because while debugging it, they couldn't stand it anymore. So, excuse me? Okay. I'm happy that they also realized that there's something to improve here. Anyhow, I think this phenomena of bells and whistles without real value to the user is more common than only this demo. It's something across many of the demos I've seen from Microsoft. It's all full of pyrotechnics, but less value to the user. And when I'm saying value to the user, I mean better usability. And usability is measured in 3 measurements: effectiveness, efficiency, and satisfaction. Effectiveness is the ability to successfully complete and perform the task. Efficiency, for example, can I order a book from Amazon? Efficiency is the amount of effort I am about to invest in order to complete this task. Will it take me 30 minutes or 30 seconds to order a book? Sometimes efficiency is measured in my investment in attention and not in time, but let us speak about the time only. And of course, satisfaction, we don't have to speak about it. So today, what we'll show you is how can we use WPF and Silverlight's abilities in order to bring real value and not only bells and whistles, in order to make better usable applications. Thank you. Okay, so let's introduce ourselves. Mr. Yochai Kiryati is an architect and evangelist in Microsoft Israel. My partner, Dr. Yaakov Greenspan, and me and all other people in UI have been working in him for a long time now. And he's a real evangelist. He loves the technology, and better than that, he understands it. Twice in my entire career, I've been working with programmers that on the day are challenging me in the design phase, and when I came back the day afterwards, I see it implemented already. So this was the case with Yochai while working on this presentation, and I would like to thank him for coming with the idea to come and give this presentation and for the enjoyable time I had preparing it. Thank you, Yochai.
Thank you, Gil. No need. There are a few open seats over here, so if anyone that's sitting over there, there are 1, 2, 3, 4, 5, so feel free. going to be a long talk, probably 2 hours. No, joking. Anyway, I've been working with Gil, or should I call him Dr. Gil Hoppert-Graf, who is one of the best UX experts we have in Israel. He co-founded a company with Dr. Yaakov, and he is managing director of a company called UI, which I'm sure you all recognize the acronym as user interface. Gil is working on a lot of projects in this space. He was one of the, UI was one of the first designer shop in Israel that adopted WPF over almost a year and a half ago, even 2 years ago, even when in the earliest beta stage. And most of the demos that you're going to see here today were developed conceptually and together with UI and some real life applications that are working today in production. So without further ado, let's continue.
Let's start. So our presentation is divided into 3 parts. In the first one, we'll try to understand what the chasm is. It's some kind of a short introduction about the human brain, its abilities, and things that it can do. In the second part, the main part, we'll show you several ways how to try to narrow the chasm, how can we help user crossing it with WPF, mainly with WPF and Silverlight tools. And in the last part, we'll step one step further and we'll introduce a new theory, practical theory of adaptive user interface. Can anyone guess where this picture was taken? That's right. This is a control panel of the control room of a nuclear plant. Anyone knows where? Chernobyl. That's right. That's right. It's not that I'm suggesting that the Chernobyl disaster was due to a human error, but I think it is clear. I don't know what happened there. Maybe it was, but I don't know. But it's clear that monitoring all these gauges simultaneously, it's almost humanly impossible mission. It's really hard, and you have to select very talented people and to train them for a long, long time, maybe months or years. And it's difficult. So there is a chasm to cross. This is the chasm we are speaking about. And I'm not speaking about disabilities. Disabilities is a very important issue that I won't discuss today. Today we are speaking about day-to-day tasks, day-to-day user, regular users. So what can our brain do? It can understand very complex things. So let's read this funny example. The SPSS processor is terminating due to a catastrophic error. Oh my God, catastrophic error. Any working data file is lost. An attempt has been made to perform an input or output operation which is inconsistent with the mode of the file. For example, direct access direct access on a sequential file. What is a sequential file? Never mind. This is a programming error. This is not my typo. This is not my typo. Programming error. Restart the processor? It looks as if an Israeli wrote this message. Restart the processor. Well, so the human brain can understand complex things, maybe not as complex as this sentence, but complex things. For example, catching a ball. For some of you, it might seem very trivial. Catching a ball, we do it every day. But this is really complex task. Try to think about it. You see the one that throws you the ball. You see the beginning of the path. Then you have to predict where the ball will go to. Not only the path itself, but the timing as well, where it be at each point. And then you have to decide where to catch it. Should you step forward, or go backwards, or stay in your place, and then you have to raise your hands, and so on. It's quite complicated, and even computers and robots can't do it yet. Let's see an example.
Good. All right, let's try it again. All right, come on, Monty, throw the ball. Ooh, try again. No, don't think about it. Just do it. It's just like a segue, right? There we go. Come on, Monty, throw the ball. Well done.
This robot is good.
Fun. 1, 2, 3.
Oh, you can catch it. Okay. So our brain can do also analyze complex things. In this picture, you can see the world champion Garry Kasparov playing against IBM's Deep Blue, presented by a Deep Junior, as you can see. In this case, computers are already superior to people, and even Garry Kasparov can win Deep Blue now in one move, only in one way. Okay. Now we'd like to move to something really more serious. I've been hesitating whether to bring this challenger example and sensitive example to an American audience, but at the end, I've decided to bring it because of two reasons. One reason, this is, I think, the most powerful example I can show you to understand the chasm. What can it cause us if we don't cross the chasm correctly? And the other one was, I was thinking to myself, if I could ask these astronauts or the families whether they are willing that I will present this example, I think the answer would be, if someone can learn something from it, if we maybe will prevent the next disaster, it's worth it. So I would like to devote this presentation to these heroes, and I would like to explain to you what happened there. So the disaster caused, I'll tell you the end of the story. The disaster caused because the collapse of the O-rings of the tank fuels. The O-rings are made of rubber, and they are sensitive to a dramatic change of the temperature. They usually reach very high temperature during the launch, and if they start in a normal temperature, then it's okay and they can do the work. But if it starts in a very low temperature, if it's a very cold day, then the delta is too big and the O-rings collapse. That's what happened there that day. And the engineers suspected something that connected with the O-rings and the weather and the temperature. They couldn't say it exactly as I told you now, but they suspected something is wrong. So they sent this paper to the man in charge, or to the person in charge, I don't know who it was, and they showed all the relevant data. They showed about examples of problems with the O-rings, and you can see the motor type, you can see the engine type, you can see the temperature of the engine, you can see the temperature of the O-rings, you can see the wind also. But the human brain of this particular person in charge and of any other couldn't understand what he's seeing here, couldn't came with the right conclusion to cancel the launch. And Edward Tufte took the same data and put it on a graph. In this graph, you can see in the y-axis, you can see the severity of the problems with the O-rings, and as a function of the x-axis, you can see the temperature of launching. And it's easy to see that the cooler the temperature is, the severity gets higher and higher, and it's exponential function. And if you look at the temperature where it was launched, this is a disaster known in advance. I can't believe that someone seeing this graph wouldn't decide to cancel the launch. Okay, let's move to something less serious. You see here in this graph, you can see the number of features in MS Word as a function of the year or of the version. And you can see how exponentially it's raising. More and more feature we give to the user, more and more complex applications. Just as a comparison, maybe I would say a demagogic comparison, I compared it to the growth of the China population. Well, this is not really important. What's important here is that we give the users more and more features. So if we could have bring to this stage George Washington and give him the intensive training and give him the office tutorial, would he be able to write a letter in MS Word? The answer is absolutely yes, because the human mind haven't changed in the last 200 years, but computers are in rapid progress. And the chasm is getting wider and wider, and actually our mission as designers is to try to bridge the chasm and to try to make better or more usable applications. So now we have reached the second part of our talk, the main part in which I will show you many examples of how can we try to bridge the chasm and to make more usable, more effective, more efficient, and more satisfaction applications. So I will base my things on a very practical and powerful model that we have, saying that when you try to analyze human-computer interaction, you should pay attention to three things: the mental model, the navigation model, and the dialogue style. Let's start with the navigation model. Well, I'm not speaking about navigating in your car with the GPS or something like that. Sorry. I'm speaking about navigating in your application. Navigation model is the user's knowledge of her present location in the application and the way to reach other specific locations. In this slide, you can see two, I would say, traditional navigation aids, the tree and the ribbon. Ribbon, it's not so traditional, but I would call it a traditional navigation aid. Here in this website that we have designed to one of our customers with MOS 2007, you can see other options, navigating aids. You can see the taskbar, you can see the back and the forward buttons, you can see the path, the tabs, trees, and the breadcrumbs. And all of these are very good navigating aids. We can build very good application with these aids. But now I would like to show you a new navigating tool that was developed in Silverlight and give us more powerful navigating tools. Well, Tafiti is a search engine that enables you to filter your results. One of the main problems that we have today with search engines that they bring us tremendous amount of results because the internet is big and there are many results. And most of them can also give you ranking, which is not so bad, but most of the users don't use the ranking of the relevancy of the result to your query. So what they did here, they gave us a new presentation of the results. You can see it some kind around the tree. The main or the most relevant results are near the stem, and the less relevant are getting away and away from the stem toward the leaves. And the user can filter the results the way you want. If you would like to focus only on the most relevant ones because you don't have time, then you can filter it very easily. If you would like to see more results, then you can add results to your search results. So this is a very powerful and simple new navigation tool. In this case, you can also move the tree around and to see the results from a different view, but I think this is a less powerful feature that they gave. The most powerful is the filtering option. You can also see here a preview of each and every result in order to be able to think whether you would like to open it or not. So let's continue. Improve dialogue style. Let's start with an exercise. The exercise is very simple. You have to try to make these exercises 12 by 12, 144, 14 times 25, more difficult a little bit, 350, 12 divided by 5, more or less 2.5, and so on. You can try by yourself to solve them. Now I will give you the same task, but it's more or less same level of difficulties. Try to solve it now. Well, can you feel the difference? It is really hard because the circle and the triangle, the square here, they drag your attention and they interfere with the main task of solving these exercises. I will show you now another option or another example of how can we drag the user attention in the incorrect time. Yochai, can you write what I'm saying?
I will try.
Are you so fast in English?
I don't think so.
Okay. Okay. So when using the word, you have a very powerful tool, the spell checker, okay, that shows you where are the typos are with the squiggly here. And usually what happens when you have a typo, you straight go back and you fix it because you can't stand the red line there.
Sorry, Gil, I can't tell.
But then what happens? You forgot what you were about to write. You forgot the phrasing, which is the main task. And now you have to rethink about it, and you are less effective and less efficient. You have to rewrite or rephrase your sentence. This is a problem that we are dragging the user's attention to the secondary task. The secondary task is writing correctly, but the main task is phrasing correctly. So we came up with WPF with a simple idea to start the spell checker in a different typing, not working always and not turned off always, but working only after you press enter or after you finish the paragraph, which is pressing enter. It's very easy to do, I think, in WPF, but this Yochai should speak about.
Okay, so as you see here, we can basically, the red squigglish, the red underline under the word came only after we actually, whatever. So it came only after we pressed the enter. So you can do it in any way you want. You can do it either when you lost focus of the text box or when you hit the send, which is very similar to what you have in an office when you want to send mail. And to do that is relatively very simple. In XAML, for example, every text element, rich text element, so just going to reload this. We're still running. Kill it. Now we can do it. Okay. So every rich element, every text element, rich text box or regular text box has a spell check, which is can be enabled, and by the default is false. So you can enable it for true. But if you want to enable it automatically for true, so you will have the same situation as we had in Word. Therefore, we need to basically just try to capture the information or capture any event that you want to handle it. So we have the preview key down, and the reason we're using the preview key down and not the key down, that is for some reason in WPF, in key down, you don't get the enter event, the key enter event. You can get everything else, but not the key enter event. And in preview, you can get also the key enter event. So going to the code is relatively fairly simple. We simply enable the spell checker, and we decided to add here another trick. So we have a timer. So the spell checker will be activated for a limited amount of time, where we have other events in the application that we can add the duration, add more time, or cancel stop the timer if there are no errors that you need to fix. So fairly easy, something tool that WPF spell checking can come out of the box for you, and you can use it as in this example. Gil?
So now that we have this option, turning on the spell checker, it's only a matter of designing. You should set the timing, the correct timing. Maybe it's printing, maybe it's sending the email, and maybe it's the enter. It's your decision right now. Okay, better mental modeling. What is a mental model? When I move my files from the draft folder to the final folder, are they really moving? I will give you another example about the mental model, a very powerful one. The shopping cart. Do you remember in the first days of the internet, when the first e-commerce sites emerged, no one used this mental model of shopping cart. And we had many problems trying to explain to the user what to do there. But once someone put this idea to tell them, listen, you have a shopping cart, then everything is clear. Since then, everybody uses it. You won't find today any e-commerce site without a shopping cart. And you don't have to train the user. They know, they understand that now they are collecting the merchandise, they put it in their shopping cart. It doesn't mean that they already paid for it. So they can do it and can relax. And then if they want to really buy it, they would have to go to check out in the cashier and pay and so on and so forth. So this is a very powerful mental model that helps the user to know what will happen if you will press here, what to expect from the application, and so on. Remember the example that I spoke about at the beginning, the one on I hate? Well, there is something good about it. It's the mental model. While telling the user, listen, this is a book, you did a job. You told him what is the correct mental model, and now he knows what to expect, to turn the pages, to turn them back, a single page each time, and so on. So let's think about another example. When I want to zoom with the mouse in Office, I press the control button, and then I use the mouse wheel. And now when I turn the mouse wheel toward the desk, should it be zoom in or zoom out? Okay, Microsoft choose zoom in toward the desk, and half of the world is satisfied and half of the world is not. And what is the difference? Why some of the people prefer this way and others prefer other way? I think it's because the mental model they have in mind. If it is a piece of paper that you have in mind, then turning the wheel toward you, it means zoom in. And turning it forward, it zoom out. But if it's a camera that you have in mind, then turning it forward, it means zoom in. And turning it toward you, it zoom out. So it's only a matter which kind of or which type of mental model you adopt. So we thought about maybe we could help the user to understand which type of mental model we choose. And it's very simple to do so. Let's open the demo and see that the only thing we did is adding a picture. That's all. When you press the control, you get a picture telling you which kind of mental model we choose for you. Okay? It could be the piece of paper. It could be the camera. And when Yochai worked on it, he said, listen, can we give the user the option to customize it? Well, this is additional added value, but I think the original one could suffice just to give him the clue. What is the correct mental model? That's all what he needs. By the way, you can see here that at the beginning we thought putting the picture in near the mouse cursor. But in a second thought we said, hey, the user is zooming in and out. He would like to see his picture. So why to put it near the mouse? So we put it aside, and it do the same job. Okay, so here's another example about how can we enhance the mental models. This is a demo where we had one screen divided into 4 panels, and we had several workflows, actually 4 workflows. For each workflow, we designed a different preset view. Okay? In some of the workflows, you need only 2 panels. In the second workflow, you need 3 of them. Here, in the third one, you need other 2. And in the fourth one, you see a different 2. But did you pay attention between the third and the fourth? This is the only place where the user sees that he has 4 panels. So only the animation helped him understand the correct mental model. If he wouldn't add the animation, I think it took him a long time to understand that it is one page with 4 panels. So only the animation helped us injecting the correct mental model to the user's head.
Okay, a word on WPF. It's fairly easy to create animation in WPF. We're not going to show it because it's not that technical talk, and there is no point of showing XAML when Gil is talking about such nice things. But the idea here is that you can play with the layout, and it's very easy to zoom in and zoom out and change the layout and change the size of each layout. Basically, you have a template here, which you can custom the controls that we have here. And all you need to do is just define the layout transformation between the different 4 panels and the sizes prospective sizes that they have, the beginning and the end of the size, and basically that's it. Fairly easy amount of to do. And everything else that is rendered in the content panel, like the image or the text, as you can see, it changes size automatically. So we don't have to do it because this is a thing that WPF gives us out of the box.
Okay, so let's reach the last part of this second part of the presentation and speak about clearer visualization. Here we would like to show you an example that was developed in Flash, but it could have been developed in Silverlight as well, very easily, as we saw today in the keynote. In this example, you can see how, with the dynamics, we can add additional dimension. If you remember the graphs that I showed you in the Challenger example, we had 2 dimensions. There it was the severity of the problem as a function of the temperature. Here you have different dimensions. Here you have the life expectancy at birth on the y dimension, and on the x-axis you have the income per person. And now you can see all the countries, or most of the countries over the world, that are arranged there on this graph. But if we would like to see the trends, how it changed across years, then it's hard to show it to all countries together with traditional graphs. But here with the animation or with the dynamics of the graph, you can see them all together. And you can also see a specific one if you would like, but what is important here, I think, is to see the trend, the movement from the lower left side to the right side, and you get the trend, you understand the thing. So with the dynamics, we managed to add additional axis or additional dimension. Usually the 3-dimension graph that we have today, not the dynamics one, they are awful. You can almost understand nothing from them because you have a 2-dimensional screen. That's the problem. Okay. Let's move on. So I would like to summarize this part of the presentation. In an attempt to bring better usability, to make our applications more effective, more efficient, and to bring more satisfaction to our users, we manipulated few things. We manipulated the mental model, we manipulated the attention, we manipulated the load. And how did we do it? We do it with the colors, with the size, with the movement. These are the tools that we have now. And I would like to show you, as a summary, another application. This is the first application that was developed in WPF in Israel. It was even developed before the blend was launched. We didn't have the blend yet then. And I would like to show you how we used all these options to get options together in one application. Just a second. So here you can see a simple option that a simple animation when you... I'm sorry, I forgot to tell you that this application brings news to the manager. And he has many issues that he is in charge of, and he would like to see only the news regarding 1 or 2 of them at this time, so he can choose which issue or which subject is more important now, and they call him to press me. See? And another nice things that you can see here is with the graphs. Here you can see how we manipulated the motion, the size, as well as the colors. When you press the graph, then you can get it bigger, and you can see everything else is going to the foreground, and we use the gray color, and this is really clear now what the graph is, and you can change between the graphs and see whatever you would like.
Okay, another word here. First, for those of you who don't understand Hebrew, this is Hebrewish, okay? And it's not left to right, it's right to left. Although WPF support, any language that you have installed on the computer. So basically, if you want to change from right to left and left to right, it's fairly easy to do. We won't show it here, but basically you just need to change a few lines of codes, mainly around the direction of the text and the alignment and stuff like that, and the text will simply change. Other things that we want to show here, so this little baby, this little control over here, it's simply a stack panel. Okay, I assume everybody are a little bit familiar with WPF. So we have a stack panel, and we have a data template that takes the information from whatever data source that we have it, and with binding, we simply present it in any way that we want to do it. The animation, as we said before, easy. And again, this information, this content right here is a mock-up, but in real life, and this is a real production application, the content is being driven from some data source. And we can easily create this with data binding, simply show the different hierarchy that we want with it. So with that, we're just going to show a little promotion of UI and move forward.
Thank you. Okay. Okay, so now we've reached the last part of this presentation, the new idea that we have about adaptive user interface. But let me start with, while we worked with WPF in the last 1.5 years or so, we saw a very, interesting phenomena. At the beginning, people were very excited about the applications and about all the animation and everything that we brought them. But after 1 or 2 or 3 weeks, they didn't like it so much. And we start thinking, what is the problem here? And we start to analyze it. And we came up with 2 main problems. First of all, not all the users are the same. We have different users have different preferences. And not everybody likes these animations and effects and bells and whistles. The second issue is that it's a waste of time. When you don't get a value from the animation, at the beginning it's nice, but then I'm aging here. So we tried to analyze it a little bit more, and we came up with this graph. Here you can see on one axis the frequency of use from very rarely used application to very frequently using the application. And on the y-axis, you see the expertise axis, from novice to expert. And applications are divided to these 4 quarters. In the lower left quarter, you can see applications that you rarely use and you are novice in it. In the upper left corner, you can see the ATM, for example, an application that you rarely use, maybe once a week, once a month or something, but since you have been using it so many years, you become an expert. In the right side of this graph or this presentation, you see the applications that I'm interested in most, the applications that are frequently being used. And you can see applications that people are novice in them, but after a time they become experts. And now think what the movement or the animations do in each and every quarter. So in the lower left quarter, movement is needed for understanding. People really need it, and it helps them. When they become expert, it just reminds them. So it's not really necessary, but it helps as well. It helps or enhance memory. And the problem is here. When you are if it's an application that is being frequently used, at the beginning, movement improves understanding. But when you become an expert, it disturbs you. It's a waste of time. And this transition, this is the problem that we realized. This is the problem, while moving from novice to expert. And what is the solution? So the solution that we came up is the adaptive user interface. And it's quite a simple idea. Let's see the first demo.
So Gil, maybe before actually going to the first demo, let's see an example. You mentioned Visual Studio there. I don't know if any one of you noticed. So how many of you are programmers in the room? Ouch. Okay.
Why did you come?
Yeah, why didn't you say anything? We will go through all the demos, all the coding, and we don't do anything else. So maybe we'll do it afterwards. So I'm assuming that most of you are familiar with this option. You go to Tools, you go to Option, and the first thing that you can see, you can animate the environment. How many checked it off? For the rest of you who didn't check it off, probably in a year you're wasting about like 10 minutes. And why you're wasting 10 minutes? Because if you checked on, then if you go to the left, then you see the movement. Okay, now the movement is nice. As Gil said, when you're first starting to use Visual Studio, there is new environment, or we added stuff like they added the new Silverlight and stuff like that today. So you need time to figure out where everything is, and the movement helps you. But for experts like us, including those who didn't check it out, so when you check it out, it's easier because you simply know you need to go, if I would see the mouse, over here, and that's it. So it's simply open. Okay? As far as the second demo that you want to show, which is this one. Nope. Not this one. Remember which one? Nope, nope, nope. go to the second demo that we have. Gil?
Can I help you?
It's the speed
animation?
up, right? The speed change, right? Yeah.
Speed change, yes.
Sorry. Too many demos. Too little code. So what do we see here, Gil?
So here you can see the animation when you mouse over the button or whatever it is, then it inflates. And you have this animation, but within time, we shorten the time of the animation. So each time you go over a button, then the animation is shortened and shortened and shortened. You can see it. Can you move more on them? You can see. So we shortened the time, but this was the first demo. And you can see actually at the end, it's really annoying because we did a mistake. We shortened only the time and didn't shorten the amplitude. So with the time, we understood that we have to manipulate both of them, the time of the animation as well as the amplitude. So let's see other demos.
And probably at the end, the end goal would be probably just to terminate the animation at all.
That's right. That's right.
Okay.
Okay. The smart tag. Do you know what the smart tag is? The little thing that is there when you copy and paste, when you paste actually. Most of the people who use the smart tag? Okay, not all of you. Actually, most of you don't use it, even though it's a very powerful tool. And most people ignore it and don't see it. And even those that use it, they use it with the mouse. So maybe you don't use it because you have to take your hands off the keyboard. Does anyone know how to operate it without a mouse? What? Wow, this is amazing. I couldn't believe anyone will know that. Yes. So the answer is Alt-Shift plus F10. That's Microsoft. It's not me. I didn't invent it. So when you try to the right click, you can also use with the keyboard. If you don't have the right click button in your keyboard, then Shift plus F10, it's the right click, and Alt Shift plus F10, it's the smart tag. So even though it's a powerful tool, people don't use it, or because they don't know about it, or they don't know the power of it, or because they wouldn't like to move their hands off the keyboard and to take the mouse. So we thought about how can we improve this problem? How can we teach the users how to use the smart tag? So we came up with a very, very simple idea. Let's put the picture much bigger. You know, the designer of the smart tag didn't want to disturb the user, so he did it very, very small, but maybe at the beginning it should be big. So we said, let's have a big picture of the smart tag, and let's have a tooltip, a big tooltip, telling him, listen, please press Alt, Shift, and F10. So if this was always the case, it's a disaster. But with the adaptive user interface, you can start with that, and with the time, you can take it off. If you can see, you can monitor it if the user used it. So after 3 or 4 times that he's using the smart tag, you can turn it off. And if you would like to go further on, then if he stopped using it after a while, then you can remind him to turn it on again and remind him, listen, this is something that can make you more efficient. So this is another example of adaptive user interface. And here is the last example of adaptive user interface, the Fitts law. Fitts law is a very old law that we use, trying to predict how long will it take me to catch something. For example, if I would like to catch the camera, how long will it take me to take my hand from here and to catch the camera? And the law is very simple. It says it depends on 2 parameters. One is the distance between my hand and the camera, and the longer the distance is, it will take me more time. It makes sense. And the other parameter is the size of the object. If it's a big one, it will be easy. But if it's a very small object, then I have to be very accurate and it will take me more time. Okay, so now how did we use this Fitts law in order to manipulate the size of the buttons? We thought about maybe we could help the users and make the most frequently used button bigger. This idea to make things bigger, it's a simple idea that we didn't invent. For example, if you look at blogs, you will see that the tags, the most frequent used tags or the most popular ones are bigger and the less popular ones are smaller. If you look at the email, the new mail in Office 2007, you will see that the send button is twice as big as it used to be or relative to the others. So this is a simple idea. What we did, we added the adaptiveness of it. So when the user uses this application, each time he presses a button, it becomes bigger. And all the others become smaller. And that's all. So with the time, you have an application that the buttons that you are using are bigger, and the buttons or the features that you don't use are smaller. And it helps you. Something very simple.
At the end of the day, to program, to code this application is relatively simple. Every time you hit a button, you simply, add to a counter, and then every time you click a button using data binding, we actually bind two-way binding to the object that we have. So the data array that actually holds all the numbers. And then we run some sort of algorithm, and you can build whatever algorithm you want. There are two versions of them. Gil will explain the second one in a second. And basically, we accumulate all the information that the user inputs as far as what he clicks and when. And then you can propagate that, and running the algorithm, because we have data binding, which is relatively easy, we can immediately affect how the button shows as far as relatively of size. You could do it for color. You could do it with anything else that you want upon that.
And it's very important what Yochai said about calculating and counting it from the beginning or for a long time. Because at the beginning, each click makes a very big difference. It makes a tremendous change. But with the time, when you have a lot of data, each click doesn't change your application dramatically. The change is really smoother. Okay. Now, let's think a little bit further. Would we like the most frequent buttons to be bigger, or should we go the opposite way? What do I mean? If you have some features that the user don't use, and you think you can help him if you'll convince him to use them, if you'll be more efficient because he doesn't know that they are there, maybe we should go the other way around. Maybe we should make the frequently used buttons smaller and those that he didn't use bigger. It's legal to do so. Okay, so it's again a decision of the designer. What are the goals? What are the usability goals of the application? And what would you like to do? It's your decision. Now that you have this tool, it's easy to do so, and it's your decision. In both cases, it will make the use of the application more efficient, and it will bring more value to the users. So now I think, what did we bring here? So we said we should change the effects. How should we change? We change the time, manipulate the time, and the amplitude of the effects. And to which direction? Most probably to make them as smaller and smaller and smaller at the end to vanish all the bells and the whistles of the application. But in some cases, like in the button size, it's not the case. So it's not reducing the animations, but maybe something different. So I would like to, and now someone might ask me, listen, won't it be boring? Did we harm the user experience? Well, this is a tough question. But from my experience, I think the answer is no, we didn't. Actually, if we leave all these bells and whistles, we harm the user experience. So, and if we take it off, they are more satisfied with our applications. And maybe the answer is different between leisure applications and professional application. I don't know. This is one of the challenges that we have for the next few months or years to try to understand or to elaborate this idea of adaptive user interface. So I would like to summarize this presentation. At the beginning, we tried to explain that there is a chasm. Users, the distance between the demands of the applications and the user abilities is getting bigger and bigger, and we should help the users to try to cross the chasm. In the second part, we show you several ways how can you help the user and how can you bring them more value and make your applications more effective, more efficient, and to make the users more satisfied from the applications. And in the third part, we added the next step of adaptive user interface. So I'd like to show you, as a summary, 2 additional demos. One, I owe Microsoft. I started telling that everything is bells and whistles, so I will show you that not everything is bells and whistles. This demo of the Contoso demo of the patient monitoring, this is something that has bells and whistles while turning the folders, but it also has real value to the user. And what is the real value to the user? When you want to focus on a specific patient, then you press the button there, and now you can focus on this patient. You see, you get a bigger portion of the screen. You can add more data, and all the navigation tool is aside. It works. It functions the same as it functioned before, but it attracts less attention. It's not in the focus. The patient in the focus, and you can continue work. This is a real value to the user. And the last example, again, I'm fond of a search engine. It's an example of a search engine. This is also developed in Flash, but could be developed in Silverlight, as we saw this morning. In this search engine, the value to the user is combined of 2 important things. One, it's real feature. The algorithm here is very fantastic. It's clusterized the results, but the presentation is very good as well. Here you can see Yochai wrote a mix 2008, and you got all the results, but they are clusterized, and the search engine brings you relevant other keywords, and it is clusterized. You can see the clusters you can see them with the colors, and you can see the list of the clusters here. And when you mouse over each cluster, you can see the connections to all the others. And when you looked at one of them, then you have a sign that you checked it already. And this is a very powerful tool. Think about it. They could give the user a simple table of all the clusters and all the connections, but it wouldn't do the same job. Here you have a very clear presentation that helps the user to navigate between the results, and I think searching would be more efficient and more effective in this presentation. So let's finalize this talk. I think we can use WPF and Silverlight tool to bring value to the user, to make more usability, to make the applications more usable, more effective, more efficient, and user will be more satisfied with it. And I think you will see the results in a short time if you give the users real value. They will love your application, they will use it, they will buy the next version, and you will see the results immediately. But you should be careful, because we have many options. We don't have any standard yet because it's all new, and you can do very nice things, but also you can do disasters. I think it's only a matter of time when I'll find some programmer that brought me a video in a checkbox together with a radio button. It's easy to do with WPF, and I think we should be careful. And in this case, I think it's worthwhile using a professional help in designing these your application. So my last point is that if you would like to learn more about it, we just opened a company in LA called Next GUI, and you can go to the site and see or ask for additional data there. Thank you very much.
Thank you. Please do not forget to fill the evals. It's very important. If you want a consecutive talk, like next year on the advance that we learn. Thank you.
Thank you.